Okay, so welcome. Yeah, good evening, everyone. We'll be starting off now. Like I said, I was going to go offline for a minute to come back. If you miss part of the class, it will still be available. I'll try and see if I can download and upload it on YouTube on my channel so that anybody that wants to go back and check what was said, you can always have the liberty anytime in the future to go back and check. So, the concept of liquid water. So let me start with saying, I am sure as Nigerians or as citizens of the world, we already know that PET bottles are already becoming a major menace. Hello, good evening. Good evening. PET bottles are already becoming a major menace, and there is the need to find a better way. We cannot tell people to stop taking water. We cannot tell people to stop taking all their juice and drinks and all of that comes in different types of PET bottles. But we need to find a better way to package these products. So essentially, the whole idea of this, in the next coming weeks, probably once in 2 weeks, good evening, or once in 3 weeks, I'm not sure, I will try to make out time to showcase simple technologies that anybody can pick up, that with minimum investment, you can actually turn it to a business idea. I believe as an individual alone, I cannot do everything. I would always be available to give my advice, to help to the best of my ability. But I believe if together we bring our heads together, we can get Nigeria working, we can get the country working. And one of the ways to do that is to ensure we are able to develop technologies within the country to meet our needs. So having said that, the whole idea of liquid water, basically, to lay a kind of foundation, I hope you can see this. So what I want us to move from is, usually we are used to, please don't mind how diagram looks. We are used to our water coming in bottles like this, and you realize the content of the bottle, once we are done with this, the PET bottle in itself becomes an issue. Yes, there are different organizations trying to find ways on how this can be recycled. However, you realize the rate at which this is produced is not equivalent to the rate at which it is being recycled. So the whole idea of what we want to do this night is to find a better packaging material for the water. So essentially, this, what we have inside will be water. What we have covering this will be a sort of water, or better still, a gel, such that we know that when this gel is discarded, the gel in itself can be easily degraded. And for some people, you can decide to even eat the gel and the water. Good evening, everyone. Thanks for joining me. So essentially, this is what we want to do. And to do this, it is quite simple. It is quite simple. So I am going to list all the materials we are going to be needing. So let's start with, and you realize these are materials that are readily accessible to everybody. So number one, we will need a weighing balance. A weighing balance. So there are different types of weighing balance. You have those ones that are found in the kitchen. The weighing balance of the kitchen is probably less than 2,000–3,000 naira. You would buy it. I have a very small pocket size weighing balance that I'm going to be using tonight. So they come in very cheap. You can have the expensive type. You don't need all of that. So we need a weighing balance. Two, you are going to need 2 medium sized bowls. That's because of the quantity we are going to be preparing. If you are preparing larger quantity, you will need bigger. So we are going to be preparing using these 2 small bowls. These are regular takeaway plates that I got at when you go for all these events. I mean, these are regular takeaway plates. Then 3, we will need 1 big bowl. Now the reason I am not putting a specific size, just ensure your big bowl is bigger than your small bowl. Essentially, the big bowl should be bigger than the small bowl. Please don't mind by not looking at the camera. I'm looking at a TV to be sure that what I am showing is entering the TV, or rather is being picked up. Number 4, so we've talked about weighing balance, 2 medium-sized bowl, 1 big bowl. We are going to need spoons. So we are going to need spoons. So what I have here essentially, I have a standard medium-sized spoon, I have a small teaspoon, and I have a bigger spoon. So I need a spoon that has like a cup. I wish my chef Eros were here to tell me the name they call this kind of big spoon. So you're able to use it to scoop. We're going to use this to scoop. So, spoon. Then we will need a mixer, number 5. We are going to need a mixer because we want to mix 2 things together. So for our mixer, I have this. I have these that I'm going to be using. We'll be using this. Again, like I said, it's a simple process, so we're going to be using this for my mixing. So this is what I'm going to be using, just like what they use in doing your milkshake and all of that. So I have my mixer. So I've listed the first 5. I want to clean so that we have it on the board. So weighing balance, 2 medium-sized bowls, 1 big bowl, spoon, mixer. So that's number 5. So I'm going to number 6. Number 6, I will need a standard cup. A standard cup. So I'm going to be using my cup for measuring water. So the weighing balance will be measuring solid. The cup will measure my water. So I have my cup. Then number 7, obviously, since I am dealing with water, I am going to need water. Now, somebody might be wondering, what of the chemicals? I mean, are you not going to use anything? Yes, we are. So one of the things we are going to be using is number 8, sodium arginate, and number 9, calcium lactate. Sodium arginate and calcium lactate. So that it is clear, I want to see if I can zoom that in for us. So sodium arginate and calcium lactate. What is he mixing? Hello, say for real, I've not started mixing anything yet. I'm just listing out the things we would need. So the 2 chemicals that we've talked about, basically every other thing are things we know, is sodium arginate and calcium lactate. So that we know what these chemicals are, I will start with sodium arginate. Sodium arginate is found in seaweed. We take it out, we extract it from seaweed. If you want to know what seaweed looks like, you can contact IFAM. IFAM has access to seaweed. She can give you seaweed easily, and I can teach you how to extract your sodium arginate out of the seaweed. Now, if you take things like yogurt, things like ice cream, things like salad cream, any of all of these, we use seaweed, or we use the sodium arginate inside ice cream. The reason why your ice cream is thick, the reason why your salad cream is thick, the reason why your cheese is thick is because of the sodium arginate. So it is called a solidifier or an emulsifier in this product. So the point I'm trying to bring out is sodium arginate is not dangerous to our health. If you rear things like fish and pig, part of the things they use in making the feed at times for this animal is also sodium arginate. And if you are a big fish farmer and you are using sodium arginate, you realize that they don't really tell you the quantity to use, which means it is not toxic to the body. I think that makes any sense. So sodium arginate on its own, it's healthy. It's something that we take naturally. I hope that makes sense. On the flip side, we have calcium lactate. Calcium is good for our body. That's what helps in bone, what is it called, in your bone and all of that, for your bone formation, repair and all of that. Now, when the bone is having issues, calcium lactate is used as a part of making the drugs that helps in treating or prevention of bone issues. So the point I'm trying to make again is sodium arginate and calcium lactate are things we eat on the regular. If you take drugs, most of the things they use in coating our drugs is from sodium arginate. I hope that makes sense. I just want to lay the foundation that it is not unhealthy. You are not taking something dangerous. So let's go into making liquid water. Again, like I said, the reason why I am calling it liquid water, it might be a bad name, but the reason I'm calling it liquid water is because the container, normally when you hold container of water, normally when you hold, I'm not trying to advertise for anybody, but when you hold container of water, you know this back is solid, the inside is liquid. But what we are trying to do right now is to do something that the inside and the outside is all liquid. So you have water that is liquid. What is holding it is also liquid-like. Hence, I am calling it liquid water. I trust Nigerians that we are awesome people, that we are very good at doing good naming. So I'm sure once somebody decides to pick this up, we would be able to come out with better names. So I am going to focus the camera now on the table. Just a minute. Please confirm we can all seal the plastics. I was trying to find a way to arrange these that all the plastics will show, so I don't have to keep moving the camera to and fro. So please permit me to get up. I'm trying to see how to set the cameras for everything to show. I must say thank you to Mr. Sam Kolakbo, my very good friend. We worked on all of this together to ensure this comes out well. Okay, hope we can all see the plastic. Don't worry if you can't see the three plastic at the same time. I will try to bring them to focus. Okay, if I put this like this and like that, I think they are all in focus. So if you notice, I have my small bowl, I have my big bowl, and I have my small bowl. You are free to arrange them the way you want. My big bowl is where I am going to do the major reactions. Hence, I am placing, once I have the big bowl, what I simply mean is I can decide to arrange it like this. I can decide to arrange it like this. It really doesn't matter. What matters the most is remember that your big bowl is where the final reaction is going to take place to make the liquid water. Now, out of my two small bowls, I will use one to start the reaction. I will use one to end the process. So one of the bowls will start the process. The second bowl will end the process. I hope that makes sense. So it's just for differentiation, because remember we are dealing with water. There is no so much color differentiation. Hence, I am trying to arrange them in a way that it is easier for me to know what I am doing. Now, for standard practice, this is ordinary water. This is ordinary water. I don't know if we can see, but what I did is drank part of the water, so we know it's ordinary water. In my big bowl, I'm going to put 4 cups. Okay, let me start with the small bowl. In the small bowl, 1 cup of water. So 1 cup of water. So whether it's the starting bowl or the big bowl, it doesn't, or the ending bowl, it doesn't matter. 1 cup of water. So take note that everything I am doing is with ordinary water. So the big bowl will take 4 cups of water. That's 1. So I take that again. My small bowl took 1 cup of water. The big bowl is going to be taking 4 cups. So what I have is 3. This is exhausted, so I'll take from my other container. Again, remember this is just ordinary water. And 4. So this is my 4 cups of water. I pour it in there. So I'm done with this. So the first thing I will be starting with is my sodium alginate. if you want to buy sodium alginate, you can get it if you live in Lagos. All those Ojota guys that sell chemicals, you can buy from them easily. So sodium alginate, this is my weighing balance. So what I want to do now, because it's more weighing balance, I have to keep the battery in a way that it doesn't run down the system quick. Okay, so I don't know if we can see this. Okay, let me shift this a bit. We are still going, I'll still bring it back to focus. I want everybody to see what I'm doing so that there is no mystery behind what I am doing, so nobody would say, oh, he probably did some magic somewhere. So, I don't know if it's showing. Trying to see if we can see it, but I don't know. Don't think it's showing. I was trying to see if I can I was trying to see if I could get the camera to come down more, but it's like it's not coming down. So let me just, so what I simply want to measure is this. So I'm going to be taking 1 gram. So first I have to tie it. What I mean by that is, you know, if you put anything on top of weighing balance, it will read automatically. So I have to cancel whatever it has weighed. So I'll be taking out 1 gram. So this is how the powder looks like. All I need is a gram. All I need is a gram. Just a gram. Okay. I'm having a little bit of air coming into the store, but so I have my 1 gram. So remember when I started, I said we are going to use one of them. Remember I said we are going to be using 1 to start. So let me move this to the side. Let's start with this. Let's move this to the front. Now because I want to mix inside here, my water is going to splash all around and I don't want that. Hence, if you are doing maybe something bigger, what is that powder? The powder is sodium alginate. Sodium alginate. So just a minute, I'm trying to log this in. Okay, so I have this ready. So I'm going to pour my sodium alginate into the 1 cup of water. Yes, sodium alginate, thank you. So I poured that in. So now I am going to mix. I'm covering because remember that I don't want it to splash. So all I'm doing is just mixing it. I want it to mix properly. So all I'm doing, I don't know if we can see it well. I could have opened it, but if I open it, it will splash water everywhere. So if I had like a deep bowl to use, that would have been better. But sorry, I don't have a deep bowl. But like I said, all I am just simply doing is mixing sodium alginate and water. It's a very simple process. As a matter of fact, this part of mixing is the hardest process in everything. Okay, I should bring my hand down a bit, okay? I was trying to raise it so that you can see the transparent part. The party I went to, they did not give us a transparent cover with all this plate. They were giving us the one that the plate is not transparent, the cover is not transparent. Everybody, thanks for joining me. Thanks, I can see your waves. I'm not able to wave back, but I appreciate, and I hope somebody would take this and try to start it and turn it into something big. So I want to see if it is properly mixed. If it is properly mixed, I would not see any particle. So there are still little particles, so I will just mix it for a few more seconds and so I'm just so you collect plastic at parties, Abby. And also they will not waste it, Mr. Sam. They don't want them to throw them away. So we are recycling it by using it. So I don't know if you can hear the sound it's making. The sound is because the mixer is touching the sides of the container. Okay, I think that has mixed properly enough. So once we are done mixing, you leave it to stand for 15 minutes. So we are going to leave this to stand for 15 minutes. I'm going to leave that to stand for 15 minutes. Okay, let me answer your question. What are the components in the mixture? Oh, the component is just sodium arginate and water. The only thing I missed is just sodium arginate and water. That is all. It's only sodium arginate and water. That's what I have here. So remember, this is the first water. So I've laid it aside. Remember, this is the one we'll be finishing with. So I don't want us to mix it up. So we'll go to the next. So remember, we said sodium arginate is gotten from seaweed. You know, I said that when we started, that sodium arginate is gotten from seaweed. You know, I said that when we started, and that sodium arginate is not a dangerous thing to us. If you take ice cream, there is sodium arginate inside. Cheese, salad cream, mayonnaise, all of these things, they all use sodium arginate for emulsification. You know, I said that when we started. So next now, so I'm bringing this back, we are going to now measure our calcium. A cup of water and sodium arginate. Yes, thank you, thank you. Me everybody is really following. You guys are awesome. You guys are awesome. Sorry, some water poured on the floor where I'm walking, so I'm trying to clean it up before I will sleep. Okay. So the next one we are going to be weighing. So again, I'll put this on top. As usual, I would have to tie it to 0. By tying, meaning anything you put on the weighing balance, the weighing balance will automatically weigh. So we have to tie to tell it to neglect the weight of what is placed on top so that I can weigh what I want to weigh. So this is calcium lactate. This is, I don't know if we can see it, calcium lactate. I'm trying to be sure it's on focus. I don't know if it's on focus. So this is calcium lactate. The first one we started with, was suppose I want to get the name. We started with sodium alginate. So we started with, please, where and how much can I buy weight? Weight balance is cheap. If you buy this, what is it called? If you buy this kitchen weight balance with 2,000 naira, I'm not advertising anybody, but check places like Jumia, Konga, 2,000 naira, you see a weight balance bigger than what I am using. This one that I am using is called the pocket size. So the second thing I'm using is, sorry, I'm trying to be sure, okay, calcium lactate. Calcium lactate. Again, I said I'm going to post this on my YouTube page. Sorry, the thing went off because I didn't use it. So I'm taking 5 grams of this. Remember when we started with 1 gram of sodium alginate. So this we are taking 5 grams. Then where do you buy the chemical? You can get it to buy at Ojota. All those guys that sell in Ojota. Then I think somewhere in Alaba also you can also get. So I'm going to 5 grams. So you understand why I have a small spoon. The ideal is supposed to be to use a rubber spoon, not a metal spoon, in case of any reaction when dealing with things like this. But because I know this will not react, I want to be sure. Oh, I didn't check the time when this started. Let's assume I've spent 4 minutes talking since I finished this. So In another 10 minutes, that's about 8:29. That should be ready for use. I actually forgot, I'm so sorry. So this should be 5 grams. Sorry. Once we are done with this process, I will take time to answer our questions. So if you have questions, where can you get hydroponic nutrients in Nigeria? So many places. You can contact Gardner Callaway. You can contact Fresh Direct. So I'm going to pour this now inside the big bowl. Remember, the big bowl has 4 cups of water. Again, I am going to mix, but this time around I'm using my bigger spoon, not the biggest, my bigger spoon. So just stir like that, and unidirectional, just continue until it dissolves. So okay, I'll answer your question now. Where can you get hydroponic nutrients in Nigeria? So you can get at Gardner Callaway. Gardner Callaway is in Lekki Phase 1. You can get at Fresh Direct. Fresh Direct is in Abuja. You can get at Nature Blend. Nature Blend is in Abuja. You can get from iFarm. iFarm is in Port Harcourt. You can get from Big Farm. Big Farm is in Lagos. You can get from PS Nutrac. PS Nutrac also is in Lagos. We are PS Nutrac. You can get from Disengulf. Disengulf is, I think, nationwide now. So many places you can get hydroponic nutrients. Hope I answered that. So okay, please let's make our questions more of what we are doing today, so we don't get too distracted. So you notice this dissolves easily. This dissolves easily. So this is my calcium lactate that I am dissolving in water. Remember, the first one we dissolved was sodium alginate. Now my sodium alginate naturally emulsifies. It forms something like a gel. When we say gel, something like pap, like a camu. It forms something like gel once it comes in contact with water. However, what we want that gel to do is, we want the gel to form a long string and surround something. So the reason of using calcium lactate is when calcium and sodium alginate meet. If you don't like science, this is the part you can just pretend you don't want to hear. When calcium lactate and sodium alginate meet, what the calcium does is it breaks off that sodium so that the alginate can form a continuous long strand. So I can form a continuous long strand as big as the size of whatever I use to scoop it into it. I don't think that makes any sense. So if I want, what are we doing today? I started in the middle. What we are doing is how to make liquid water. The process of making liquid water. By liquid water, what we mean is, we are all used to buying, again, I'm not trying to advertise anybody, so I'm sorry. We are all used to buying water in containers like this, and the issue is, you realize once you are done with the water, the PET itself becomes a nuisance. Not just water, your drinks, our soft drinks, and so many things. So the question is, what if there is a way to package water without using PET bottles? What if there is a way to package juice without using PET bottles? So what I am doing is a method that anybody can use to package any of these things. Now, I am showing you the basics. Anybody that is interested, you can take it up and develop. I believe one of the reasons why science has not gone so far is, whatever little result we get in research, we either write it as a publication and keep it in books, or we hide it to ourselves and we don't share it. But I believe if we are willing to share, it would probably, I think it would help in faster development. So what I am doing is trying to share knowledge. Like I said at the beginning, I am going to try to do videos as often as I can, showcasing different technologies from irrigation. I mean, take for example, if you have a field and you want to apply nutrient, why go and pour your nutrient solution when you know rain would fall and wash it off easily? when you can envelop your nutrient inside these containers. When we can envelop our nutrient inside these containers easily. So this has fully dissolved. So we are waiting for the 15 minutes to be complete. Then we will take this and put here, and the process is done. Then so once we take our sodium alginate from here, which is already in water, and put it here, you are going to immediately see a kind of a spherical structure being formed around the water. Remember, once these two comes to each other, the water will be pushed to the middle. You know, we mixed it with water. So it will automatically push the water to the middle and form a sphere around it. What I mean is, oh, this has broken. I was trying to bring out one. I want to so you understand what is going to happen. So by the time I want to show you understand what's going to happen, this is what we are going to try to form. Now, once this comes in contact with this, remember we mixed this with water. What is going to happen is the whole alginate, which is the gel-like structure, is going to come out and form a spherical structure to envelop the water it was mixed with at the middle, such that if I should burst this now, you'll see the water come out. I don't know if you can see the water now pouring out on my hand. Oh, my hand is blocked. I don't know if you can see the water. So this is the water originally, and I can taste my water back, normal water. So whatever water, so you can see, then if you can see me, okay. So what I'm trying to say is, I can scoop out the water at the middle and drink. I have my water back, and this can easily be degraded without issues. This can easily be, this is not a nuisance to society. So basically, this is what we are trying to do. Don't know if it's up to 15 minutes yet, no, most. So please, if you have more questions, you can ask. Then also, we are still running the free training on soilless farming for schools. If you have a secondary school, how long does the spherical structure last? It will last as long, so far so good. To the best of my knowledge, a month they are still there. A month it is still there, nothing would happen to it. I have not had a chance of keeping it longer, but a month it's still there. Nothing would happen. It does not get destroyed by heat, so it's not like, oh, once the temperature around becomes high, it will just burst open. No, it doesn't. We are waiting for it to be 15 minutes, then we are going to do this and put here. So once we, remember what I said, once we take this and put here, what this calcium is meant to do, the calcium lactate, is to break the bonds of the sodium and the alginate. So once it breaks it, it forms a sphere. The water that they were mixed with, it begins to envelop the water immediately at the middle. So you now have water at the middle and the sphere on the outside. What is the use of this? Now, the use of this for right now is to find a way to eliminate the use of plastics. The use of PET bottles, not plastic, use of PET bottles, one. Two, if you are into farming and you want to supply nutrients, with this method you can supply nutrients at the rate at which you want, because the plant will have to break the gel and take water gradually such that evaporation, erosion does not push all of these things away. So that's the use. Again, somebody else might watch this and you are able to think of better ideas of what these things can be used for. Like I said, my vision is to share as much as I know for free so that other people can take this thing and reciprocate. Can it be transported easily? Yes. Yes, it can be transported easily. It can be transported easily. Okay, so we are going to take, remember, this is our sodium alginate. It's still like water, but right now, I don't know if you can see, it's more like wax. It's looking now like wax. So we are going to take it. We'll take, so is the issue with creating an, I don't think, expensive container. It's not really about creating an inexpensive container. It's more about creating something that is not a nuisance to the society, like pet bottles. If you follow the news a while back, I think it was Indonesia, one of the pasta that they used during their anniversary, I think about 50, 60 years ago, was washed onshore, and they realized the nylon is still intact. So we will drop it gradually in there. So I'll take another one. I'm not able to see it because I'm too close to it. I'll drop it. I'm not able to see what I'm dropping, but I hope I'm dropping it well. Sincerely hope I'm dropping it well. Maybe we'll stop at 3. That last one I didn't drop it. I meant to drop it properly. Remember, the calcium would want to break it, so you don't want it broken and it forms is kind of a slope. I can't see it well because, so we are going to give it 3 minutes to develop. Remember I said it's breaking the bonds. It's breaking the bonds. So we are going to envelope our water in between. So once it has developed inside here, we'll bring it out. The essence of this third container is this is ordinary water, you remember. So once you put it here, it stops the reaction. So I'll come close to see if I can read your question. Can you put this in the refrigerator? Yes. Yes, I have a YouTube channel. Yes, I have a YouTube channel. People use plastic because it is cheap. Actually, this is even cheaper than plastic. This is cheaper than plastic. This is cheaper than plastic. So my YouTube channel, like I said, I'll post it on YouTube. You just go to youtube.com/c/my name, Samson Opoli. That's my YouTube channel, and you will see it there. So that nobody would say, oh, he removed the camera to do some quick magic. So let's bring it back down. Yes, you can put it in the refrigerator. I have a couple of guys who even use it to do other things. So it's developing. I don't know if it's up to 3 minutes yet. I don't know if it's up to 3. Can it be poured directly from the bowl instead of using the spoon? No, the reason why you don't want to, we have different level of spoons that you can use of scooping. If you pour directly from the bowl, remember what I said, that the calcium will break the bonds of what you have here. So if you are pouring it in like that from the bowl, immediately it is touching the calcium, it will be breaking the bonds. So it's going to form small, tiny pellets. We don't want tiny pellets, we want bigger. If you have a spoon that can scoop as much as the size of this container, better, because it means at the end of the day, you are going to have a structure as big as this container. I hope that makes sense. I hope I answered your question well. I hope I was able to answer that question. So the idea is we don't want it spilling, we don't want it breaking into whatever kind of pieces it likes. We want it to break into the kind of pieces we want. To the kind of pieces we want. Okay? So that's why we are not pouring. Okay, so I'm going to try to take it out now. Again, remember I said because the lighting here is poor, so it's hard for me to see. It's all looking, the water and the gel look alike. So remember what I said, one of the first things you need to do is when you bring it out from here, you put it inside ordinary water so that the reactions can stop. Now I said once you take it out of the gel, okay, I can feel it, but sorry, it's all looking like water, but I know it's not all water. So I'm trying to find them. When you do this during the day, it's much easier because you can actually see the gel well. But right now, because they are both transparent, maybe if you probably want to do this for the first time, it might be good to use a, can't find, I keep picking them and dropping them. So let's take Yes, I should have sieved out the solution, Mr. Pranky, you are right. Unfortunately, I don't have a sieve here, but I've been able to take it out. So I will put it so nobody will say, oh, you did magic again. So I'm putting it on my plate. I didn't pick it out properly. I broke it in trying to bring it out. Let me see if I can fake smaller one and drop where I would see it. We have been able to form some already. I just wanted to see. Okay, I think I can see this one better. I think I can see this one better. Sorry, I don't have sieves at home. So when next time you invite me for your party, share sieve. Okay, so this will come out better. Why not sieve out the solution? Yes, I don't have a sieve. I had a sieve at home. All I needed to do was actually use the sieve to pick it out. I didn't allow that to develop properly. Okay, let me use from these ones that have come out. So essentially what we are trying to form, I will hold it to the camera so that it is a bit clear. So these are the things we are trying to form. I don't know if we can see, this is liquid water. And like I said, if, let me take one, I don't want to burst so many open. Let me use a plastic that we can see. So you can see I can hold it. So I don't know if we can see it here. So if you burst this, can honey go through the process? I have not tried honey. So if I should burst this open, you'll see there is water inside. So the idea is to envelope water within this, such that I can easily now use this to carry my water. So it's already almost an hour. I hope we learned a thing or two. Again, you can always go back to the YouTube channel. I will try to post it there and I will try to post as many technologies that we can try on our own. Thank you for joining me, and have a great night. Yes, it is durable for mobility. Yes, it is durable for mobility. Thank you very much. Thank you very much. And don't forget, we still have our classes available for students in secondary school for free. The school can write to apply to learn how to grow without soil. You can learn how to grow without soil. So you can see this is ordinary, this is water, and I have my vegetables growing indoor. It's a simple system that we want to teach students how to do, and they can always commercialize it.